Okay, so now we will look at the demand and the supply of the different fractions that come out of your petroleum during fractional distillation. Okay, so these smaller hydrocarbons, the shorter ones, are high in demand because they can burn easily. So remember, they have a lower percentage by mass of carbon, so it's easier to burn. So they are high in demand, easier to burn. We burn it in the cars and in petrol station to produce power stations to produce electricity. Okay, and also the smaller ones or the shorter ones, they are used as feedstock, the starting material, to make all these kinds of chemicals, right? Like your cleaning fluid, cosmetic, paints, plastics, etc. So these short ones are high in demand. The larger hydrocarbons are lesser in demand. So there's still some uses like your lubricating oil and the bitumen. There's still some use, so there's still demand, but the demand is much lower. Okay, so fractional distillation cannot meet the demand for the smaller hydrocarbons. Okay, to meet this demand, excess heavier hydrocarbons undergo cracking to form lighter fractions. Okay, so when you go and dig out the petroleum and the fossil fuel from the soil, because it is a mixture and all the fractions, the light ones as well as the heavy ones, will be distilled out. There's no segregation. Okay, so when we do distillation, yes, we have the light ones, but these smaller and the lighter ones cannot meet the demand. Okay, so as a result, what to do to meet this demand? What do? There is the heavier hydrocarbons after you use for bitumen and lubricating oil. We have what we call excess because nobody demands them, right? So this heavier hydrocarbon, we perform cracking to form lighter fractions. Okay, so definition of cracking. What is cracking? You must know is the breakdown of long hydrocarbon into shorter alkanes, and hydrogen. Okay, so when you do cracking of this long bitumen or the lubricating oil, which are actually all alkanes mostly, right? It will break down to shorter alkanes, the carbon-carbon single bond, alkenes, shorter alkenes as well, the carbon-carbon double bond. It can also produce hydrogen. So hydrogen is commonly used as a fuel. We use it to make ammonia. That's the most important within the O-level syllabus. Okay, importance of cracking. Question asked me, why do we perform cracking? Why is it important? This is your standard answer. Heavier fractions are lower in demand, but high in supply. Okay, and they are converted or break down to lighter fractions, which are higher in demand but lower in supply. Okay, short chains of alkenes are used as feedstock to make plastics, chemicals. So this one I already tell you, the shorter chains one, why are they higher in demand? We use it to make naphtha, or rather it is a bulk of these short chains are naphtha, and naphtha is used to make all the common chemicals that we do. Okay, cracking is performed under high temperature. So cracking of the same molecule under different conditions can result in different products. Okay, and then we also have what we call catalytic cracking. So be careful, if they just say normal cracking, this is high temperature. Catalytic cracking means you need to have a catalyst. So what does the catalyst do? It speeds up the reaction by lowering the activation energy. Okay, common catalyst memory work is very, very important. You have to know silicon dioxide, aluminium oxide. Okay, these are the two catalysts that we commonly use for cracking, breaking out long hydrocarbon chain into shorter hydrocarbon chains, the shorter alkane, alkene, and hydrogen gas. Okay, so in a molecule of, for example, octane, which is C8H18, Okay, and then I tell you octane undergoes cracking, then it will be broken up. So different conditions, maybe for example at 500 degrees Celsius, I can break your octane into C4H8. So I can break it up into a alkene with the carbon double bond. Okay, this one is your butene. And I can break it out into the butane, C4H10. Okay, at for example 800 degrees Celsius, you can break it out into ethane, C2H6 ethane. You can break it out into butane, C4H8, and ethene, C2H4. So this cracking 500 degrees gave me an alkene and alkane. This one gave me 2 alkenes and 1 alkane. And then the next example, maybe at 1000 degrees Celsius, okay, it broke up into my still C4H8, C2H4, 2 times of your C2H4, the ethene, and your hydrogen gas. Okay, so this is an example where it breaks down into alkenes and hydrogen gas. Okay, the important points about these examples over here is, right, you have a long chain, you can break it down into alkane, alkene, and hydrogen. It doesn't matter what you break it down into. What is important is that the number of carbon atoms and your hydrogen atoms at the end of it adds up together. So no atoms are lost in cracking. Okay, no atoms are lost, your formulas or your equations will be correct as long as no formulas are lost. Okay, so uses of petroleum. So petroleum, again, this is your crude oil that is dug out from when your dinosaurs died. Petroleum is a finite energy resource, so it is non-renewable. Okay, and there's a large increase in petroleum due to industrialization and population growth. So forming factories, building factories, right? Why do we have to build factories? Because population growth, you know, you have to have a lot of chemicals, you have to have a lot of plastics, etc., etc. Okay, so this one will lead to high demand for the oil. As a result, right, depletion of these resources takes place very, very fast. Okay, and then also that when you use petroleum and when you burn your petroleum, okay, it can contribute to air pollution as well as water pollution. If you are not sure how, look at your air and atmosphere. Complete combustion gives you CO2H2O. Incomplete combustion gives you carbon monoxide, which is a pollutant. Okay, so what are some of the solutions that we can apply to these situations that we face when we use petroleum or when we use crude oil? So reduce the fuel consumption by reducing cars. So take public transport, you share the transport, you know, one vehicle on the road transporting 40 people rather than 2 people in the car. Use alternative energy sources that are renewable, solar energy, wind energy. Okay, reuse items so that you don't have to keep reproducing them in the factories. Okay, it will also prevent, minimize waste disposal and then minimize landfills. So this leads to lesser land pollution. And then recycle. So plastic, it cannot be broken down, so that we can actually recycle as well as reuse plastics to stop making new plastics.